up, everyone? So I find I have more projects than I have time to work on them, so naturally we're starting a new project. This is game, here I'll show the game first. So this is Super Auto Pets. It's almost like an automated card game, more so than a video game. You pick and choose a little team of animal pets, and you roll a dice on the bottom here, and you get new pets each time you roll one. You can save some for the next round, but when you're ready, you hit end turn and you go into a little fight. It's like emoji Pokemon. And then, yeah, each pet has like a different ability. Some shoot little pellets, others just attack. Yeah, other team won that time. And yeah, so years ago, I did machine learning research for my job. How is this a coding stream? It's not coding yet. It will be in a second. So that's Super Auto Pets. Here, I'm going to do my best to code up an AI bot. Yeah. We'll do Super AI Pets, the name of our repository. And so like here, I don't know, I got a pig, so I'll buy another pig. Be another mosquito. Out of money, hit end turn. One of the challenges with making an AI to play this game in particular is it's not clear how you would even code up something like this. And how you would get the AI to make, like, for example here, the AI can buy new pets, and when it, or it can buy food to give the pets. I can give, like, a honey pot to a pig or something, and that gives it a new ability. Okay, Super Auto Pets Automatic. This is Super Auto Pets. Auto Super Auto Pets. Super Auto Pets Auto. We'll work on it. Or like, I can give an apple to the mosquito or something. Which one would be good? Yeah. And that gives it slightly better stats. Or I can use, the money I have to roll. Like, well, actually, probably here it's best to stack the mosquitoes and buy a swan instead of leaving the mosquitoes split and stacking the swans. So you see, it's like, each turn you can buy animals, you can buy food, you can re-roll for different animals or food, you can change the order of the pets on your team, or you can combine pets on. So it's like there's, 4 different actions that are all qualitatively different that we have to code up. Whereas for, making an AI to play something like Super Mario Bros, a little bit more straightforward because, its actions is like jump, and move in each of 4 directions. Which, the 4 directions, yeah, that's 4 different possible inputs, but they're all qualitatively the same. They're all the same kind of thing, just moving. And, a score metric in Mario is pretty easy. It's just how far right can you move on the screen. For most levels. There's some levels where you have to do more clever stuff. But here, the way it works is we have 10 lives, and the goal is to win 10 battles. So if you can win 10 battles before you run out of lives, then you've won the entire, I guess, match. Arena, actually. And so it's like, it's not even clear how you code up a score for this. So, well, I thought about this, so I'm not just going in 100% blind. Nah, I'm not going to make it. The plan is, we're going to code up an AI that just looks at a team. Well, we're going to code a few things up. First, we have to code up, all the stats for the different animals. Then we have to code up something that can, take a list of animals, levels, held items, and simulate a battle between those two teams. And thirdly, we're going to have to make, this is the AI part, probably a neural network using Q-scores that looks at a team and just gives a score for how good or bad it is. Oh. Come on, man. Spam. Yeah, this is kind of weird, actually. Okay. I'm using Streamlabs to stream right now, and the spam report and ban button within Streamlabs is not working, so hold on. I open up the YouTube stream dashboard just so I should be able to ban people from the chat. These bots in chat are bad. It's like, actually, I'll bet there's a spam comment on, oh, no, not on the cookie clicker yet. Usually is by now. Anyways, okay, we'll go to content, live streams, control room. Okay, did it work? There we go. Report. Okay, there we go. New AI, 84% will find a girl for you. Appears to be an AI claiming to help you find dates. And is probably just after money or getting viruses on your computer. Or not. Not worth finding out. Okay. The fun part now. We're gonna have, you know, like a pet as a class. Right now, our goal is just brainstorm like what coding structure do we want to use to play this game. Have pets, and then probably we'll also have a team of pets as its own thing. You know, and this will take in a list of pets as its team. Uh, 0 to 5 possible pets on the team. You already got a girlfriend. I got a wife, man. Unless the AI is claiming that it's, you know. Oh, hold on, I gotta close my window. I seem to always stream when my neighbors want to do yard work. Well, that's a lose-lose for the spam, because, you know, finds me a woman that's not my wife, that's a problem. And if it finds my wife, it's kind of creepy that it would be able to find that information. I know nothing about coding. That's okay. Take it down. I don't know that much either. But I know enough to scrap together an AI. So we're going to have one class. A class just means an object in the code. So we're going to have one kind of coding object to represent a pet, another coding object to represent a team of pets. And then I guess we're going to have different strategies. Where a strategy just means, you can almost think of it as like a math function that takes, you know, something as input and it gives you a number as an output. So class score, that doesn't communicate it well. Now we need to make a new code object. So team is, well, okay, pet object is going to store all the information about how a pet fights. A team is going to store a list of pets and we'll be able to simulate a fight. Score will be able to look at a single team and give a number for how good it thinks that team is. That number might be like the expected number of victories that team will have. That number might be just a probability, like 0 to 100% that team will successfully win all 10 of the victories needed to complete the arena. Score might be like the average amount of damage it expects that team to deal for each match. I don't want to call it score because this isn't this object isn't the score itself. This object is the mechanism that gives out scores. Oh, okay, so we can call it a ruler, because this is what we're using to measure the teams. I don't know, my style of coding is I like pausing, and if it takes me an extra 3 minutes to come up with an intuitive name for something, I find that it's more fun and worth the 3 minutes to just get the cooler name in the code than just do like, like name this thing score function or something. Or we could name it like a critic or something. There is information about how a pet fights. Here we have stores 0 to 5 pets. Maybe we'll actually have a different class that simulates a fight, in which case the team is just like we wouldn't even need an object for the team, because we could just do like team equals and then the list, and I would just be like at 1, at 3 or something. Probably easier to keep things straight in our heads if we have a class, though. Yeah, okay, so we can do something like, we'll have a function here, self other. Cool, and we'll pass for now. I guess actually. Return true. So right now this is just coded up to be as if a team always wins any fight that it challenges. So we'd have like team 1, this team at 1, 2, 3. Team 2 equals same thing, and then if we want to simulate a fight between these two, we would write team 1 dot fight team 2. This should be easy enough for us to keep track of mentally. Okay, that's looking pretty good. And then, yeah, pets have a few abilities. So we should start with its base, health, and attack. What order those come in the game? Attack first, then health seconds. Attack, health. Later on, we will have to code up 3 versions of attack and health, because there's the base attack and health of the pet. It's a permanent boost to its attack and health, and its temporary boost to its attack and health. So some boosts For instance, if I put a giraffe here, at the end of the turn, it'll give a permanent stat boost to this mosquito. However, the kangaroo, in battle, if the thing in front of it attacks, it gets a stat boost as well, but that stat boost vanishes at the next round. Maybe add a get current health function. Oh, well, yeah, we'll have to get to that when simulating a battle. We're not even there yet. Right now I'm just brainstorming, how do we package up the information about a pet for, like, when you're in the store screen? What is this? Does this area even have a name? A shop, I guess we could call it. This will be a good first start. Right now we just want to get our general, like, code hierarchy looking good at a high level. So our ruler will measure how good a team is. Yeah, there we go. Is this all we need? I think so, actually. Here, I'll expand on how I want to do this. So we'll have the Super Auto Pets library. We're gonna have 3 files here. We're gonna have AI library, Super Auto Pets library. So Super Auto Pets library is gonna actually hold our pet and team setup. Maybe also shop. And the shop, I'm not sure how to describe that actually. Maybe for now we'll just write like self.gold 10 self.pets equals, just do an empty list, self.food equals, yeah, that looks pretty good actually. Last week I've been bitten by so many mosquitoes. Are you reminded of that because of the mosquitoes in here? There's a little forest creek near my house that I like to hike in. And we've, haven't had rain where I live in Southern California for a few weeks. No, not that, a few months actually. Like month 4, maybe, month 3. But the creek in this little forest valley is, still running, and so it's where all the, now it's where all the bugs are, so if you hike down there, you get attacked by bugs. Gold, pets, food. And then what we want to do for the shop is, so we could put team into self.team equals, just do none for now. This will do def, so a new method called options. And this is going to be an iterator in Python, meaning it just kind of repeatedly spits out different things as it runs. And what it's actually going to spit out is more shops. So it'll spit out a new shop for each choice that you can make in the current shop. That might get tricky for swaps of pets. Well, I guess what we could do is for okay, we won't worry about the order of the pets for now. Because it won't be that hard to actually just literally make the score for all, I think 60 different ways you can order a team of 5 pets. Yeah, so we won't worry about swaps because every other choice you make, you can only make a limited amount of them. So re-rolling, buying a pet, or buying food, all reduce the amount of gold you have in the shop. Wait a few more rounds while we talk. So yeah, if I roll, gold goes down up here. And if I roll again, gold goes down. Again. This keeps going down. Then, if I get a pet I want, buy it, and again, gold goes down. But swaps, the AI could potentially have a problem where it thinks, oh, it would be better if I swapped this mosquito and giraffe. And then it looks at this team and says, oh, it would be better if I swapped the giraffe and the mosquito. And then it looks at this team and it says, oh, it would be better if I swapped. Yeah, so we'll deal with that problem later. For now, the shop will just take care of rerolls, buying pets, and buying food. Oh, this isn't looking good. Oh, hey, there we go. First victory of this arena. Nice. Level 3 pig. 2 swan, reroll, save the giraffe. I've played hundreds of arena matches at this point, and I don't want to do this just to get better at the game. That it? Yep. So that's this arena done. Lost all our lives. Gotta go back to the main menu. So options. Yeah, we'll just call it that. Turn an empty list. So I don't know if it'll be better to do an iterator or return a list here. The only difference is an iterator returns results as it calculates them. An iterator, and then something that's not an iterator just records all its results in a list, and then when it's completed, the list hands the whole list back. So kind of worse because if the function takes 5 minutes to run, you sometimes don't find out there's a problem until 5 minutes in. Whereas if you do an iterator, maybe it's calculating 100 results, but the first one is done in 5 seconds. Then as soon as it passes you that one back, you can tell that something's wrong. Okay, this is looking pretty good. About how a pet fights. A list of pets. Oh, I capitalized L. Pets. And simulate a fight. Shop. Maybe we don't actually have a team in here. What we do is we hand it a team for the options method. I don't know what else to call this thing. It's just The shop. Yeah, can... Okay. Make a list all possible purchases. Great, that's looking good. Yeah, I feel much better about this now. At first, I felt kind of overwhelmed about like just all the different possibilities of purchases you could do and how you would try to train an AI to make those. This is a much simpler approach. Then ruler AI lib. So we're gonna have a few possible different ways to measure a team's stats. Yes, let's go back here. We're gonna have our pet. It's gonna have its, attack and health. Maybe we have attack and health are its base. Yeah, base attack, base health. Then we need to store boosts for its attack and health. Attack. So attack perma boost and health perma boost. Those are too long of names though. We've got to store its level as well. It starts, yeah. Starts as level 1. Base attack, base health equals... Yes. Maybe we just pass in a tuple, so a pair of numbers. Yeah, okay, let's do this. We hand it stats. Base stats equal stats. Then we have its boost, which starts at 0, 0. And then a temporary boost, like say from horses or in battle. I guess just from horses is the only place this would come up, because in battle we're going to simulate health and attack differently. Maybe we just do like current health or something like that. What is this even equal to? Just stats, I guess? Okay. This is worth laboring over because making sure this is intuitive will make all future coding much easier and faster. Ooh, that's nice. Health and attack have the same number of characters. Let's start at level 1. Base stats. Let's just do boosts, and we'll figure out temporary versus permanent boosts later on. Attack up. We'll just make these the permanent ones. We'll figure out the temporary ones later. Permanent or permanent? Permanent. Permanent. Okay, cool. I think we just do base attack plus self dots. Okay, then if we want to get the current health of the thing right now, we're just assuming that's equal to, yeah, its base plus its boost. Funny sentence. Health up, attack up. Okay. Now in AI library, we're gonna have a few different ways to score stuff. So we could do like stat score. And we'll have a bunch of different objects for different strategies. This one, some stat score. Okay. So here, a team's worth or score is just going to be, I think, the sum of its stats. Rulers measure self team. You just do, I think, score equals 0 for pet and team. 4 plus equals pet dots. Oh yeah, I guess back here, because we're using, yeah, we can just change these to attack and health. Nice. Attack plus. Great. just adding up its stats. Okay, so this class measures how good a team is by just adding up its stats. It's a pretty good place to start. I'm not even sure we need a class for this. This is pretty much just a function. No point wrapping a single function in that class. We do stat measure. And another idea I had that's probably slightly better than this is to just note that when you have a bunch of pets, like in here, a pet that has like high, like, how do I say this? See if I can get an example. Okay, I guess the pigs are a good example. These pigs are kind of weird. Because they have super, for, level, or tier 1 pets, they have super high attack but low health, which means they pretty much kill anything they go up against, but also die at one hit to anything they go up against. In other words, having one team member with high attack and another team member with high health is worse than having, one weak team member that has low health and attack and one strong team member with high health and attack. Like, the worth of a pet is not the sum of its stats, but their product. So in that case, we could do something like this, where a team's score is the sum of the products of the stats. I'm sure what to call these. That's okay, and this one would probably be a little bit better. Okay. But then later on, we're going to want to define a Q-score metric that we tweak with a neural network. And that's going to be the interesting part of this project. Okay. Let's see if we can outline what we'd run in this main area here. Actually, okay. Probably going to be actually something in here. Yeah, okay, so we'll do we got to name our AI Super Auto Pets Auto super auto pites. Oh, ASAP. Cool. So that's okay. And essentially, what we're going to want this AI to do, we can hand it I guess choose choice. We're going to hand it a team. Yeah, a shop and a team, and ask this AI to pick the best action. Okay. And we can do that. Here, I guess we can just do yeah. We can pick which one of its functions we want it to use to score the teams. Okay. U-score is just 0 for the time being. Action. Essentially what's going to happen for action, we've already started coding this, is the shop can give us a bunch of options. Okay. I'm going to try to maximize the score of its team. The expected score or something? Let's do 4. Do shop team in shop options team. Okay. It's looking pretty good actually. Maybe we actually have the shop hold a team. Maybe not. Possibilities is a good word here, but it's too long to use in code. Okay, yeah, the different moves it can make. And then back at the shop, I have to have our program reorder teams as well. Yeah, I think it'd be easier to actually make team a member variable here. Yep, something like that. And it returns a list of shops. Okay, cool. Okay, it's looking good. Self.moves. Add on a new tuple, which is going to be here we'll write score equals self.score function. New shop. So here's a question whether the score should also take into account what's in the shop. We can figure that out later. New shop.team. Right now we're just going to score the team regardless of what's in the shop. That should actually still be pretty good. This is also getting into like the porta potty problem in math. Maybe this thing should actually score shops. Because the question of when to re-roll is going to be a little complicated. I guess we could just have it re-roll when okay, here's a theory. We could frame this as like, so we have a method to score a team. Let's just say we'll build up to it, but let's just say we get there. We have a method that can score a team well, like well in a way that actually reflects how likely that, you know, like a total ordering of teams. Meaning, you know, if you match a score with a low team against a score with a higher team, the score actually pretty reliably tells you which is going to win. You know, maybe not 100%, but that's okay. At any, you know, let's just say you're in the shop. Yeah, and right now I have essentially 3 options. So I could buy the horse, I could buy the beef, well, I guess 4. I could buy the beaver. 5 options? Okay, so I could buy the horse, I could buy the beaver, I could put the honey on a pig, or I could put the honey on a duck. Or I could re-roll. So what we could do is, in our simulation, you know, we create the team of horse, duck, 3 pigs, the team of beaver, duck, 3 pigs, the team of honey, duck, 3 pigs, and the team of duck, honey, pig, 2 normal pigs. We hand all 4 of those teams to our team scorer, the thing that measures teams, and, you know, have it tell us what it thinks that team score is, and, you know, presumably the score would be better than this team here, because all 4 of those teams only, you know, add fighting power. And let's just say it, you know, adds 3.6 to the score or something. Each one of those purchases costs 3 gold. So let's just say the average score increase per gold you're getting is then 1.2. Then what you could do is this is going to take a while, but you look at every possible option you could get by re-rolling. So for, you know, if you re-roll, you know, we're on tier 1, so presumably all it's, you know, all it's going to appear is tier 1 stuff at presumably equal odds. So we're going to get a random selection of 3 tier 1 pets and a random selection of 2 tier 1 foods. And that could be 2 apples, 2 honeys, or 1 apple, 1 honey. Yeah, and this is going to be pretty crazy, but what we could do is look at the average increase to score that each pet or food offers. Yeah, so maybe let's just say, we don't have a mosquito here, but let's just say for whatever reason, adding a mosquito to this team makes it way better. Let's see, what are the odds of getting a mosquito? There's 1, 2, 3, 4, 9 pets here. We get 3 slots. Let's just say it's a 1 in 3 chance about. It's math, but 1 in 3 chance of getting a mosquito. Maybe it's increased to the score. It's hard to put into words. I'm trying to say that by looking at all the possible things pets you could get from a reroll, we come up with the average increase to score you could get by re-rolling and then purchasing a pet. And let's just say that amount turns out to be, I don't know, 5.6 or something. Well, to roll and then purchase would cost 4 gold. So 5.6 divided by 4 is, what is that? 1.6? No, 1.4. And since 1.4 is better than 1.2, we would say yes, it's worth it to re-roll. On average, we'll get 0.2 score more per gold than if we just bought right now. Okay, that actually sounds pretty good. So in that case, we're still only ever going to evaluate teams. Yes, so that's correct. In which case, shop does not need to hold a team. We'll call this the menu because what this function does is it lists out all possible purchases. So after a purchase, we get a new shop and a new team. Okay. That's pretty good, actually. Because here, I'm just gonna have shop self.tier starts at 1. Def roll. Okay. Maybe we'd pass tier, probably easier to pass tier in as a variable here. So tier, so we could also give it some pets, some food. Okay, pretty good. And we'll have to code in something to take care of, I think like squirrels, which actually affect the price of the shop. Or swans, which give you extra gold. Roll. guess we could just do turn none for now. Should get some better adjective than score to describe how good a team is. It's a noun. So how did score? It's power? Maybe it's strength, actually. Seems like a good word. Strength equals self dot measure new team. Alright, that's looking pretty good. And our shops, yep, have gold as a variable. We could do here price equals shop dot gold minus new shop. Okay, that looks pretty good. So, you know, if we have a squirrel, food items cost 2 gold, we buy one. It would give us, you know, whatever increase to the team's strength at the cost of 2 gold. Okay. And then the score of this purchase will just be increase in strength per price. Strength per gold. Strength divided by X. Yeah, okay. Increase in strength per gold. It's not bad, actually. Okay, so we have okay. And then we get best score, best shop, best team equals self sorted, self dot moves, reverse equals true, first entry. Nice. And now we want to figure out man, this is tricky. Next, we want to figure out the expected value of, you know, of an increase in strength we could get from re-rolling and purchasing something from the re-roll. So, like, expected re-roll equals, I don't even know. No. Shop. Okay, I guess what we do here is do roll options. Oh, this doesn't even take into account selling pets. I totally forgot about that. Huh. Oh, you know what? We might have to do something like this just for normal purchases without a reroll too, because when you level up a pet, it will, if there's room, randomly add a pet of the next higher tier to your shop menu. Nothing is straightforward, man. Most of this stream is just brainstorming. Okay. Maybe we need to think about this as the score that each possible new purchase can add to the team. This is also where now we're kind of also overlapping our plan now with where Q score comes in. Q scores and I'll just look this up. No, this isn't what I want. I want brand familiarity. Q score AI. Is it called Q score or is it? They name it something else. Q learning. Yeah, it's called a Q score, isn't it? Here's the equation. Yeah, here we go. Oh yeah, this is okay. No, I had the right word. It's called Q learning. Okay. Yeah. Q score is just kind of like a crutch that helps AI estimate the long-term payoff of a choice versus its immediate payoff without having to think like 10 steps ahead. Actually, really kind of neat shortcut. programming AI. Actually, yeah, right now the way I'm doing this would not use Q-score. I'm trying to do the future look-ahead part by hand. So like for instance, yeah, I guess the way we would do this with Q-score is to hand not just the team to the AI for evaluation, but to hand both the team and a shop to the AI for evaluation, and it outputs a Q-score for that team and shop combination. And let's just say there's no good options in the shop to buy. Then the Q score might place, a high score on re-rolling if it was trained correctly. Yeah, and yeah, the way I'm doing it wouldn't have like if we code it the way I've been doing it right here, the AI wouldn't be able to look ahead more than one move in advance, which is bad because actually could it if we had like because we are still using a neural network in this setup, which is to measure the strength of a team. Okay, so I guess there's this actually, okay, so this the strategy we're using could develop like, 5, 6, 7 turns later look ahead ability for its strategy. It could this strategy, this setup could create an AI that could think multiple 5, 6, 7 turns in it. Only if we measure a team's strength in the correct way, because there's two ways we could measure the strength of a team mentioned earlier, but I didn't realize it would create this big of a difference. One is, the strength of the team is its likelihood to win 10 rounds before losing 10. Its likelihood to win that arena session. The other is to use strength almost as kind of a global ranking for all possible teams in Super Auto Pets. Meaning just if you have, teams A and B, the strength should just reflect which one of them is going to win a match. Like just one match, not long term which one will win the arena, but just if you put team A and B up against each other one match, which one is more likely to win? It should 99% of the time be the team with the higher score. And I was going to use a neural network to calculate that score because that actually shouldn't be. That should actually be pretty straightforward to do. Like we shouldn't have to use Q learning or what's it called? Convolution. There might be some places where we can use convolution here. Convolutional neural network. Yeah, convolutional neural network is just a neural network which is designed to recognize patterns in the same pattern in different places in the input, usually for images, because like if you want to recognize whether or not like there's a dog in an image, you don't care, if the dog's like right here, like 5 pixels to the left, you just want it on the dog. So in our case, we have something similar, which is, we just want to probably actually do convolution on the shop purchases available. Like, we don't care if we're buying a cricket from the first slot or the second slot. We just want to know how much buying a cricket improves our team. Apple. Yeah, long term, we'd probably want to go with how likely a team is to win all 10 rounds, not just the likelihood of winning a random match. Maybe we could do both, actually. Let's just write that out. Well, we've got the thought well formulated. So if we go in here, just write this on top of everything. The big question currently, do we measure the strength of a team as A, its likelihood to win a single random match, or B, it's likely to win an entire arena session. And this is tricky which one of these we choose. Actually, yeah, and this, okay, so option B gets a little more complicated because this team right here, Pigs in the Duck or whatever, maybe say it has a 40% chance of winning the arena if played optimally. From our current round, I think we're on round 3 right now. But a team that has a 40% chance of winning an entire arena session from round 3 onwards probably has like a 1% chance of winning a total arena session from like round 8 onwards. Because by round 8, everyone has way better teams. And this team of a bunch of level 1 pigs and a duck is no longer competitive for the super pig. One. And that gets tricky. It's really tricky. Okay, so what let's do here is, since the simpler method is to have our AI measure just how likely a team is to win a random single match, let's just theory craft and see how far we can go building up a general AI using that, neural network subcomponent. I found, I've done, I think, about 2 or 3 years of work as a research and developer at software companies for machine learning. And I found that 19 times out of 20, you get better results by spending a couple days thinking about how to solve a problem strategically than you would just blindly throwing a neural network at it. And, there's that 1 in 20 times where the right thing to do is throw a neural network at a problem. But most of the art of being a good machine learning creator and researcher is knowing when those situations are. And actually usually keeping them to a minimum. This is not looking good. Yeah, so like even here, one of the strategies I do that I don't know how an AI would replicate it is I try on like rounds 3 and 5, this is a pretty common strategy, to level up my pets. Because if you can do that, it gets you a very early level 4 pet, or, gets you a level 4 pet when most people are still getting their first level 3s, or a level 3 pet when most people are getting their level 2 pets. Sorry, tier 2 pets. Oh man. Keeping tier and level straight in this game is messes with your brain, man. It's like we would want the AI to be able to discover that kind of strategy. How would we get it to discover that kind of strategy? Come on, man. If it's only able to score the strength of a team going into a single random round. I don't know how we would do that. I think the only... If we want an AI that can discover strategies like that, I think the only solution is that we have to give the AI access to the entire shop. It's tricky, man. Okay, maybe what we do is... That option occurred to me when I started this. Actually, I think it was the first one, and I shied away from it because I couldn't imagine how you would even program it. What we do is we give... Yeah, we give our AI just all the data. The current round number, a list of pets in the shop available for purchase, how much gold we have left, how many lives we have left, how much food we have, or what food is available for purchase, and what pets we currently have on the team, and all the stats, levels, held food item abilities of those pets. And then from there, all we ask the AI is, hey, how likely is this team to win an arena session? That's all we want to know. Not how likely is it to win the next round, not what is its expected cumulative, product of stats. Just how likely is it that this team will win 10 of 10 battles in the arena or it runs out of lives. And what's nice is with that metric, it's more, we'll need a beefier neural network to do that, because now the neural network, instead of just taking in 5 pets, takes in 5 pets, a victory number, a round, or a life number. I don't know if we need to give current victories and lives in, actually. Actually, maybe we should. Just because, there's some if you have, right now we have 3 lives left, and if we lose, we're done. But, using snails, which give you boosts only if you lost the previous round, I've won arena sometimes using snail strategies. And so, there's some strategies that only work if you have lives to spare. Oh, and we need the AI to freeze. Be able to decide when to freeze stuff too. What I was saying was the reason I didn't want to code up this. So that's... I'm buying the snail. Sell the snail, this one in there. The reason I didn't want to throw all this information at the AI is because I couldn't imagine what the AI would hand us back. It's possible, you could purchase shop slot A to team slot A, so you have A to A, A to B, A to C, A to D, A to E, B to A, B to B, B to C, B to D, B to E. And so right there, that's 20 options. With the food, it's another 10 options. And with reroll, so it's all in all, that'd be 40 different options that this thing could hand us back, which is probably too many that... it's just, because the number of connections in the last layer of our neural network is going to be probably about the number of possible moves squared or times a large constant like 30, and training all those connections is going to take a really long time. what would be easier is if instead of, like one of the reasons it's easier to have, train an AI to play like Super Mario or something is because it only needs to output 5 values instead of, like the 40 I just listed out, which is, like, are you holding down the up button, yes or no? Are you holding down the down button, yes or no? Are you holding down left, right button, yes or no? And are you holding down the jump A button, yes or no? You need to take into account like illegal values, like you can't hold down both the left and right button. But for the most part, that's only like 5 choices, or even 2 if you just think about it as which direction you're facing. So we want to do pig, pig, save the giraffe. Alright, and this is it if we lose. Yep, this is it. Okay. Okay, in that case, we gotta re-architect all the code we just wrote. Okay, so big question, do we measure the strength of a team as its likelihood to win a single random match or its likelihood to win an entire arena session? The answer, B. Oops. Because it's probably impossibly so, because it's easier for the AI to invent long-term strategies this way. Whereas, if we go with A, where it's likelihood, if the only score we're creating is the likelihood of the team we have to win the next match, what the AI is going to do is it's going to maximize the fighting power of its team each turn with 0 thought for how its choices are affecting that team's fighting power 2 turns from now, or 3 or 4 turns from now. Which is a problem because a lot of the best strategies require making plans for, like, specifically for round 3 or 5, where you try to unlock future pets, or buying a bunch of fish, which by themselves don't add much fighting power, but when you combine them and level them up, give a larger boost to your team's to the fighting power of your team as a whole than, say, like an individual beaver or duck would otherwise. Or like pets that, you own, like pets that you sell to get a boost. Like I think ducks do that, beavers I think do that, pigs do that. It's like one possible strategy would be that, the AI loads up on pigs for turns like 1 and 2, and come turn 3, it levels up the pigs and sells them so that it unlocks, 2 or 3 tier 3 pets and has money to buy them. That might not be a strategy it finds, but that's a possible longer term strategy that wouldn't optimize that team's fighting power on each individual round it plays. So it's easier for the AI to invent long-term strategies this way, because this is the only way the AI can invent long-term strategies. And then also, option A We could add some, like, handwritten logic to option A to try to create long-term strategies. Like I was doing that down here with re-rolling and expected roll score. But the problem with that is it's only going to be able to look ahead with longer term strategies as well as we program it to. And the whole point of creating an AI to do this is we want it to discover new strategies we didn't know about before programming it. So option A could be coded up with longer term strategies in mind. But doing so requires either a lot of hand-coded instructions, either one, that all longer-term heuristics, all longer-term decisions be coded up by hand, which means the AI won't find any long-term strats we don't already know about. Or two, yeah, we adjust the strength measurement to take into account longer term information, like round number, victories, lives, but in this case we're just drifting back towards option B. Okay, that works for me. Okay, so how do we want to code this up? Pretty much going to be the same. Team, pretty much the same. Yeah, okay. AI, I'm gonna get rid of all this stuff. Okay, so the Q score is going to get handed maybe we want to make a whole new class here, like a session, an arena session. Okay. Yeah, that seems like a nice intuitive way to do this. So we have a session which holds our arena session, which holds our current team and a current shop situation. A number of lives and a number of victories so far in the current round number. Maybe we don't pass the shop in then. We do like self dot round equals 1. Self dot lives equals 10. Self dot wins equals 0. And then self dot shop equals, going to make a new shop object. I'll probably actually hand the shop the tier to work with. Okay, that looks pretty good. We're going to start at tier 1. Okay. Huh. And RAI here. Yeah, we're gonna have it score. We're gonna have a function called measure, and this is going to measures how likely a an arena session is to end. Yeah, okay. There we go. Okay. Measures how likely an arena session is to end in 10 victories. Pretty good. Yeah, and so this is going to take into account the round number, how many lives we have, all that stuff. And then the AI will learn as time goes on that like this probability will should go down as you have less lives. That the likelihood a given team will win an arena session depends on what round we're in. So like a low tier team might be pretty good for round 2 or 3, but really bad for round 7 or 8. This AI will learn that. This is the automatic super auto ASAP. Automatic super auto AI. That's funny. Alright, its name is ASAPA. Oh, how do you spell APA? Like Aang. APPA? If it was AAPA, we could have done APA's. It's the name. Okay, we'll go with ASAPA. We're going to do ASAP. Zappa. Okay, we'll go with ASAP. For now, we'll just return I think 0.3 0.25 is the random amount. Meaning if you're, in an arena session and every player in the world plays totally 100% randomly, and you are too, I think you have a 25% chance of winning arena. And that number just comes from the lives, to victories ratio. So on average, you need 10 victories to win arena, which means 10 other people have to lose. And each time a player loses, I think their life count goes down by 3, not just 1. It's not 1 life per loss, it's more than that. It starts at 1, I think, and then it's you lose 1 life, 2, then 3, 3, 3 for the rest of the match. So, in other words, if you win 10 times, you've probably taken about 20-something lives away from other people, meaning about 3 other people have gone out and have lost the arena because of you. So for every person that wins, about 3 people lose, so 1 in 4 people win. Those are just the purely random. Oops. Purely random odds. Great. I think the shop can handle, future options. So def children. Or child in self.shop. Yeah, okay, we'll call this self.shop.options theme. Looking pretty good. And we need, yep. New shop, new team. Can we do that? Do shop equal shop 1. Something like that. We're also gonna have to make a pet generator too. It's in child equals session new team shop. Put those in the same order. And then we just copy over the child's round equals self.round. There we go, yeah. And then we yield the child. So we're creating an iterator method within session. And this will iterate over all, you can almost think of when you're in the shop in Super Auto Pets, you're playing an arena session. And at each moment, maybe say there's on average 4 different purchases you can make. each one of those branches off into a new arena session. Maybe some of those reconverge, some of them don't. This iterator will spit out one after another all the different possible new arena sessions you can branch out into based on the purchases you make. In your shop.options, calling it menu. Right now we're just returning an empty list. Okay, it's looking pretty good. Okay. I guess what we would do here for ASAPA is we'd hand it a session. Yeah, okay. Yeah, okay, so we'll have a method here. What move does our AI make? I make for a certain what move does our AI make at a given point in an arena session? Looks pretty good. What's interesting is this setup won't work perfectly for doing, say, not arena, but what is it? Tournament? Where you do like a tournament bracket with like 10 other people or whatever. And that's kind of what we want, because there's probably actually slightly different strategy that you would use in tournament versus here. Anyways, going through the children of the session, we hand this thing. So we have our AI called ASAPA, and we say, hey ASAPA, here's a game that I have in progress. What should I do? And then you hand it the game. Maybe we should just call it game. Yeah, let's just call it game. It's way more intuitive. We hand the ASAPA, our AI, a game, like midway through, say what you want to do, and what ASAPA will do is generate a list of all the different, different games that you could branch out into from the one you hand it. So maybe there's 5 different options it has, there's, actually on average, there's probably going to be a lot. Maybe 4 different pets it can buy. Maybe 2 pets on your team it could merge together. So that's 6. 3 food items it could buy. Each one of those could go on a, one of 5 pets. So that's like 20 different options there. And then lastly, there's the option of re-rolling. Rerolling will be a little tricky. We'll figure that one out later. I guess what we could do is just like re-roll, I don't know, maybe like 20 times and have our AI score each new session that each of those 20 re-rolls makes, and then we just take the average and it says like, okay, that's about how much better my game gets if I re-roll. Yeah, this is getting tricky. I'm not even sure how to count, how we're gonna set up like freezing a pet here for future use, but we'll take a shot at this. If this doesn't work, we might have to fall back on plan A, which won't have the best long-term payoffs, but still might be interesting to code up. Okay, so for each child, self score equals self dot measure child. Then we append score and the child to our set of moves, and when we're all done, best score, best child equals sorted moves, reverse equals true, 0. Okay, so what we're doing here, taking all the different moves we can make, scoring them all. We're going to use learning and neural networks for that. Ooh. Sorting them so that the one with the highest score is up front, and then just taking that, and that's the move we make. I guess we actually just return this. Okay, that's pretty good so far. Probably also want to have another object in our library for like super auto pets library. Maybe like not even an object, but like tier 1. We have a list. Yeah, and then in here we just have like, you know, beaver, duck, pig. Can I remember every tier 1 pet? Mosquito, ant, cricket, beaver, duck, pig, mosquito. That's 7. I think there's 9. I'm missing. I refuse to look. Oh, the fish. And the otter. Great. I can remember all the tier 1 pets. Yeah, that's perfect. Here we'll have to define them. So we could start by just defining, their base stats. So like fish, pet tutu. Probably gonna have to custom code all the abilities that these pets have. So we'd have something like this pet's what happens when you sell this pet. Start spacing this a little better. Yes, what happens when you sell the pets? What happens? The pet levels up. Yeah. What happens, or what did this pet do? What does this pet do at the end of turn? What does the pet do at the start of a turn? Love your permaculture and Minecraft series. Oh, thanks. It's my I don't know if it's the one it's the most meaningful series to me. It's not the most popular or exciting, but it's the series I care most about. That do at the start of a turn, and Stiff, knockout. Some pets have abilities that occur when they knock another pet out. What does this pet do when it knocks out an enemy? And there's a lot of stuff here. What does this pet do when damaged? Sold, leveled. I guess we also have okay. I guess like most pets, their ability is just going to be one of these things. So for instance, like for fish, we might do fish dot leveled equals team. Yeah, some of these take the whole team. It's like when you buy a pet, pass in the team. Sell a pet. It's in our team. End turn. Team. Start turn. Here we're going to have to pass in team and enemy. Damaged. This is actually a good place for inheritance. I don't even know if you can do class inheritance in Python. Doing damaged. That's only gonna happen to battle. Okay. Some pets are also gonna have to receive like the shop too. Like for instance, Squirrel, its start turn ability affects the shop as well. Okay, just trying to do one thing here, so like fish that leveled lambda. The fish ability, tell team or pet in team. Pet attack up. Plus equals fish.tier. No, fish.level. Fish.level. Okay. Fish.level equals. Does this work? Like, is this like I don't even know if this is how you can use Python correctly, but we're overriding a method. So a fish is this is what defines a fish in Super Auto Pets. It's a pet with 2 attack, 2 health, and its ability is that when it levels up, it adds to the attack and health of all other pets on the team its own level. So when a fish, its own level -1. Yeah, so when a fish levels up to level 2, it adds 1 to the health and attack of everything else on the team. When the fish levels up to level 3, it adds 2 to the health and attack of everything on the team. Okay, cool. What's cool is with our little simulation here, we could almost make our own game, which is like unlimited level auto pets. So you could get like a level 4 or a level 5 fish or something crazy like that. Okay. I kind of want to do this stuff in its own file. So we're going to have all this the pet library. Oh yeah, maybe we call it petlib and gamelib. It's like the gamelib game library. Actually, pretty much have all this stuff. So the classes simulate Super Auto Pets. And then Pet Library will have the specific data for each pet. So we have fish, with defines the fish. Pig equals so sold shop so this here's what we'll do a pig now. Pig's ability and we do shop dot gold plus equals pig dot level. Yes, that's correct. It's a one-liner. Great. And then fit or not. Pig dot sold equals. Okay, that's pretty good. This thing just reloaded. Sometimes you lose changes. Now we got him. Okay, so what this block is saying is that a pig's base stats is 4 and 1. Its ability happens when it's sold, and specifically, it's that the shop gains 1 extra gold for each of that pig's levels. So if you sell a level 3 pig, you gain the usual whatever 3 gold, but then you gain an additional 3 extra gold. Okay. And now the tedious part is coding up every pet. Okay, let's see if we can get through tier 1 today. That'll give us something to work with for simulating battles and testing stuff, and then we can get everything else working and make sure this is a project we actually want to follow through with before we take the extra 2 hours to code up tiers 2 through 6. Duck equals pet. Just gonna put 0, 0 in as a placeholder. We have 9 pets. We have 3, 4, 5, 6, 7, 8, 9. Should probably. Oh, let's. You know what? Let's order the pets the same way they are ordered here on the list. Okay, ant. Pig, fish, cricket, beaver, otter, duck, horse. Great. It does raise a question though, is what is the bee count as? Bee and what is the cricket summon? Other cricket? It just summons another cricket, okay. What if we want to code that up, man? Ghost cricket, maybe? Something like that? Okay. Okay, let's give ant a shot. Two, 1. Okay. Ant equals pet 2, 1. def ant ability self team. This happen when it faints. We're gonna have to give enemy too. I wonder if we should just do team enemy shop for every ability, even if we don't need like the enemy or the shop or whatever, just so it's the same input variable types for every ability function. I'll try it this way first. That might get weird. I don't know what it would. I have a sense it wouldn't be worth doing. Okay, so the ant ability, it's its sold ability too. So ant.sold equals ant ability. Okay. Ooh, I kind of want to call our AI not Asapa, but Asada, Carne Asada. Okay. Carne Asada. Okay, we're making progress. Just do, yeah, new session display. What's our first error? Session is not defined. From pet lib import session. From guy lib import Asada. Cool. Yeah, we got to define this ability. I think we're gonna need random here. What's the random range? Just looking for if the range is inclusive or exclusive. I guess we can just test that. We've had 100 random numbers. Random.rand range 1 to 2. Just quick throw pass in there. That is not defined. Okay. I mean, pet's not defined. Okay. Oh yeah, we're doing game, not session now. GameLib 64 Cricket is not defined. Okay. Big next. Fish. Mosquito, beaver, otter, duck, horse, bee, ghost, cricket. Okay. Oh, come on, man. Both of these. I don't know. Okay. Can't import session from PetBib. Where's that happening? Oh, yeah. Great. And game has no display. No, we have not coded that. Okay. What do we got here? This simulates the game of Super Auto Pets. The game is a team, shop, and your round lives wins. Cool. Missed out. The new games. Probably, it would be more correct to call these game states, but I don't want to type all that out or have that tedious clutter. I like if I can just glance at code and all the words are simple. List out the new games created by all possible purchases. Obviously, if your gold is 0 in the shop, then there's no children. There's no new game states you can create, in which case we'll have to program the AI to simulate moving to the next round when that happens. Play current game info in the column. Okay, it looks pretty good. Okay, so for display, what do we want to do here? What's the order it gets printed out here? Gold lives wins round. Gold lives wins round. Okay. So gold, self, dot shop, dot rounds, lives, wins, round. Lives, wins. That wins. Okay, doesn't look too bad. Nice. I'm going to print these all out on one line. I guess I'll do data. Put these in here. Nice. Okay, so that's the data we want printed. Okay, see how that looks. Nice. Next we gotta print out the team. Okay, that's not too hard. I think we just do join. Yeah, okay, there we go. And then this should fail because we don't have... What? Oh, we don't have any pets on the team. That's why it's not failing. Okay. Okay, whatever. Shop 1. Probably actually hand this the round number. When we're creating a new shop object. We gotta code up the food too. We'll move pet to the pet library. Okay, that's pretty good. Okay, we print out the team. Next we do shop bus. Can we just do like str shop? Yeah, maybe this, okay, so this is going to be a deviation from how the data is displayed in the game. I think we'll just give the shop its own display method. just like that. Nice. Right now, I don't think we're actually using the class team, so I'm just going to delete it. We can probably get through with a team just being a list of pets rather than a class which contains, among other things, a list of pets. Shop display. Okay, so now we got a code. Shop's display method. This is no longer true. Yep, okay, that's looking good. Okay. I'm going to keep the round as an internal variable in a shop because that will let us, roll easier because the pets and food items we create when we roll are going to depend on the round number. Okay. Create a new shop by rolling for new pets food. Finally display. Print shop info. Print shop info. Great. In this in game. Gold. Nice. Pets. Okay, that looks pretty good. See if I can combine these into one actually. Okay. Hey, it's looking pretty good. Okay. So right now, we're creating a new game and there's nothing available for purchase in the shop because we haven't programmed the shop to offer anything for purchase yet. Let's do that. Oh, you know what? We can use the roll method to do this. So instead of creating a shop, yeah, okay. So maybe what we do is we have two methods here. We have restock and roll, where roll just calls restock, but also decreases how much gold you have. So roll as a method just calls restock at the cost of 1 gold. So randomize the pets and food available for sale based on the round. I guess we don't need to see that. Randomize the pets and food available for sale. Great. Okay. Let me just call it randomize. Great. Oh yeah, this is much more intuitive. Okay, so randomize re-randomizes the pets and food. Roll calls randomize at the cost of 1 gold. Okay. That's looking good. And then pet lib. Oh my goodness. I guess the first thing to do is calculate the current tier available. How do we want to do this? This is going to be round divided by 2. Because the tier goes up every 2 rounds. Oh, actually, I think that's about it. Yeah, so the tier, the round plus 1 divided by 2 truncated. So if you're on round 5, the highest tier available is 5 plus 1 divided by 2, which is 6 over 2, which is 3. So there's tier 3 pets available. You're on round 8. The best is tier 4 pets. And sure enough, 8 plus 1, 9 over 2 is 4.5. Int just truncates it down to 4. Perfect. With one last critique, once you get past, there's no tier above 6. What we want to do is put just a little catch in here in case tier is like 7. I guess just, this will be more intuitive. Tier greater than 6, tier equals 6. We could do that with a minimum call as well, but it's easier to glance here. Tier 6 is the highest. Or just... There are no pets higher than tier 6. The tier goes up every odd number round. Okay, that's looking pretty good actually. Shoot, and this raises the question: how many food items and pets are available? I think food is always 2. I almost need like a generator or something. Like pet gen and food gen. For like the pet generator, like you give it a tier, and it gives you a random pet back up to that tier. This is getting tricky. Bigger. See the text easier. Oh, round is a... God, that's a function in Python. Probably call it round number. Just so we're super clear. Okay, let's just start with 3. Figure that out later. 3 pets, I mean. We can make lists of lists, right? In Python. So what if we just do... something like that? Oh, you know what? Yeah, we could put bee and cricket as... Actually, shoot. What do those even count as? Like... Yeah, okay. I want to see... Yeah, like what a bee and a cricket is. Like, do those in the game, are those tier 1? Are they, do they have a tier? Because we have to make sure that we don't offer a ghost cricket or a bee as a purchase option in the shop. I wonder, is there any advantage to like leveling up a bee? Oh yeah, okay, so it's a ghost cricket is it's zombie cricket, okay. And they are tier 1. This is kind of tricky though, because now what do we do with these two? Tier 1 pets that can't appear in the shop. What do we do with that? Anyways, there's the tier 1 pets that can't appear in the shop. There are no tier 0 pets. Let's do this. I'm adding in this empty one here so that the index matches up with the tier. Because obviously the index is 0 enumerated and the tier is unitally enumerated. Okay, not too bad. Totally forgot to do this. Oh, one. Okay. So random.rand range does not include. What about rand int? Oh, okay. Same thing, but includes the top number. Got it. Okay. So then we got to import from lib import tier list. That should do the trick. And we'll update these numbers later. Up top. So we gotta. Pets and food. Come on, English, make a list of pets and of food. Great. Self.pets. Append. You do choice again. Random choice from list. I think random does this, doesn't it? Random.choice list. Very easy. Good job, Python. Oh, you know what? Let's do random.choice. Available pets. Looks pretty good. And self food. Append random choice available food. Nice. We can even make this a little smaller by just doing this. Yeah, that's nice. 3 pets. So 3 pets. End of. Two food items. We'll have to figure out how the scroll is going to change this, but this will cover most cases. Then available pets. Start with an empty list, and then 4 high and range. Okay. Actually, I think this would be better if we 0 enumerated the tiers. List. I guess we just go tier list. This is okay. We gotta do tier number. There. So the available pets is the first tier number tiers. Good way to put it. That gets the job done. Notes at index 0. Tier 1, note at index 0. Okay, that's clear enough. Available pets. This is a concise way. Python concatenate list of lists. Do that. You could, double index it. Pet for pet in tier for tier in tier list. That looks pretty good, actually. Is that the right ordering? These specifically item and sublist. Yeah, okay. You do these backwards, don't you? Oh. Something crazy going on. Huh. So GameLib. From PetLib, import tier list. Oh, right. Forgot we moved pet over to this class. Yeah, okay, we gotta... I don't know why I gotta do it this way. It always screws with my brain. Random is not defined. Available food is not defined. No, it's not. Instead of tier list, let's call it pet tiers. Okay. And in here, this is now pet tiers. Also have food tiers. Make our own file for the food. Petlib. Food tiers. Cool. Right now it's all just empty. We do food. Great. Okay, we can put those in later. Cannot choose from an empty sequence. Really? You don't have a way to do that? Okay. There. Got an apple. And it does nothing. It'll make this thing happy. Ooh, look at that. Okay, we got our output. And I'm just making a basic, food to string setup for this custom class where it'll, print out the name. I just got here. How much have you done so far? So far, we have brainstormed how we're going to set up the AI. So we're going to hand it like a partially completed arena game and just have it tell us a probability, like 0 to 100%. What's the chance that you win this arena match, given your current team and what's in the shop, how much gold you have, how many lives you have left, and how many victories you already have. So you hand it, and that's where we're gonna probably just throw that stuff at a neural network, and it'll give us a probability. How likely is this setup, this situation you're in right now, to result in winning the arena? And then the way the AI will play the game is, at each moment in the shop where it has spending money, it'll look at all the different ways it can spend the money and what new teams or new shop items those result in. And for each of those, it'll apply its, will win probability function, and just pick the one that gives it the highest probability of winning. So that's our game plan. So far, I've outlined the code libraries, have added just like the functionality for like the first few basic pets. And this is so adding all this in so I can simulate, in Python, like 100,000 games and let the AI practice against itself. And later on, we'll code up the ability to have this thing take in a game. Like if we're, if I'm playing and I'm stuck and I want help, I can either by hand type up, what's on my team, what's in the shop, how much gold wins, losses I have, and this thing will tell me what to do, but we're not there yet. I just want to, right now, code up a basic simulation of the game. It's just working on displaying the current game situation. We got to put string methods in our food and pet classes. Okay. So this should now... Yes, okay, so it's displaying apple here. Because right now, that's the only thing we're putting in the shop. Actually, I guess I could do honey as well. It's tier 1 foods. So there we got 2 apples. Apple honey, 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 apple honey, honey apple. Okay, great. So it's actually randomly picking foods. We gotta do the same thing with pets. Yeah, I'm gonna worry about their abilities later. And their attack, for that matter. It's just gonna be too much to take in at once. For our purposes right now, a pet is nothing more than a level, attack, and health. We'll do abilities later. Gotta get names in here as well. Great. And then for converting a pet into a string to display, what we'll probably do is do its name, some brackets, and then in between those, it's attack. It's getting kind of long. Yeah, okay, let's... self.stats equals... its attack, its health, okay. Yes, okay, now we gotta put names in for all these. PS11. There's the tier 1 pet data. Hey, check that out. Let's put up the stats quick. Get through this. Cool. Okay. Cricket, 1, 2. How many of these I know? Mosquito, I think, is 2, 2. Yes. Beaver is 2, 3, or 3, 2. I think 3, 2? Yes, 3, 2. Okay. Otter. 1, 2. Yeah. I've played this game a couple times. Duck is 2, 3 for sure. Yeah. And horses 1, 2? 2, 1. Almost got all of them. Okay. This is looking pretty good actually. Let me fiddle with this a bit. This is pretty cool now. So here it's, simulating a game. But, we click run, it sets up a new game. Yeah, right off the bat, we could buy a horse, a fish, or a mosquito, apple, or honey. 10 gold. Hey, this is super cool, we're getting somewhere. Although, those brackets look weird to me. I feel like it might be... That's it. Maybe. What if I take that off? Do like a colon. That looks kind of weird. Dash? Nah, I think I like parentheses the best. Hey, this is pretty good so far, man. Okay, well, we got to a point where we can code up the opening generation of the shop and an arena match. Alright, it's been 3 hours. I'm gonna call it quits for the stream for the day. Thanks for hanging out, y'all. Catch y'all next time.